hello. Welcome back. The topic today is distributive property. Wow, what does that mean? When you see the word distributive, there we go. What does that mean? If I say distribute, right. So think about Halloween, right? You're out going trick-or-treating. You come to the door, you say trick or treat, and you wait for candy. You hold out your bag, and you've got some friends with you. So there's the four of you, and everyone's holding out the bag, and the person says, "Oh, you guys look so cute. Here's some candy for you, and you, and you, and you." All four people got candy, right? What if you went and you knocked at the door and you said, "Trick or treat"? And the person says, "Oh, you guys look so cute. Candy for you, and you, oh, you don't get any." And give you some candy here on the end. They skip that person. Oh, that's not fair. That's not right. We're not going to do that. We're going to distribute. That means everybody, all four people are going to get some candy. That's what distributive property means. It shows that how you use it in math. Wait a minute. Did you get your paper and pencil? Pause the video. Go get it. If I write 45 plus 60, I want to write it a different way. Why do you want to do that? All right, you need to understand that right now we're learning math right now that's going to let us do cool math later. So right now we're practicing some skills so that maybe, if you're wondering why I do that, sometimes we just have to learn how to do it so we can use it later, okay? So we're practicing a skill we need. So 45 plus 60, I want to use the distributive property and rewrite that. How are we going to do that? Well, I'm so glad you asked. Do you remember before when we were using GCF and LCM, the greatest common factor and the least common multiple? We used upside down division. We're going to use that. Let me show you. We're going to review real quick how we use that. What number can we divide out first? Can we use 2? 60, 0. Ends in 0. That's even. Oh, but the 5's not even. Remember, the even numbers are what? Ends in 2, 4, 6, 8. Who do we appreciate? Me! Hey, don't call me a 0. 2, 4, 6, 8, 0. So if it ends in 2, 4, 6, 8, 0, we know it's even. And we know we can divide out a 2. But 5 is not even. No 2. What about 3? Does 3 go into 45? Yeah, it does. If you're not sure, you can use a calculator, right? 45 divided by 3 equals, is it a whole number? No decimal. Yes. And 60 divided by 3. Yep, that's a whole number. Good job. 45 divided by 3 is what? 15. 60 divided by 3 equals 20. All right. We already know we can't use 2. If we couldn't use 2 before, we know we can't now. It's always out. Can I use 3 again? Nope. 20 is not divisible by 3, so that won't work. It would have a decimal. Can't do it. What's the next prime number? 5. Let's try 5. Yep, 5 works. Remember, every number that ends in a 5 or a 0 will always be divisible by 5. So 15 divided by 5 is 3. 20 divided by 5, you got it. It's 4. And I know that I'm done. Do you remember why we know we're done? Because if they're counting numbers, they're right next to each other, we know there's no more common factors. All right. Ooh, let's review. What is the GCF? Yeah, you got it. Good job. the GCF, 3 times 5, it's 15. Remember, we multiply them together, and we multiply with a dot because we don't want to use an X. So we're going to say it's 3 times 5 is 15. That's the GCF. Good job. What's the LCM? Do you remember how to find that? Well, forget that pen. You see my L? The LCM is going to be 3 times 2. We're going to multiply those. Multiplied by 3 times 4. All right, so 3 times 5 times 3. 3 times 5 is 15. Times 3, 45. Times 4 is what? I'm not sure. What am I going to do? Yeah, I could use a calculator. Or I could just multiply it out. 45 times 4. 4 times 5 is 20. Carry the 2. 4 times 4 is 16. Plus that. We get 180. The LCM is 180. All right, that was a good review. We found the GCF and the LCM. We just multiply. For the greatest common factor, we multiply the side, the least common multiple, the whole m. All right, that was good practice, but now we're going to go back. All right, hey, we're back here again. It's just like magic. All right, now we want to know, how are we going to use this to show how we could add 45 and 60 a different way? Let me show you. I'm going to use the GCF, 3 times 5. $15. 3 times 5 equals 15. And now I'm going to use some parentheses. And now I'm going to write the leftovers. Bring down the 3. Bring down this plus sign. Bring down the 4. Closing parenthesis. That's it. So we used upside down division to find the 15 as the GCF, bring down the leftovers, 3 plus 4. That's it. I think maybe we should check it. Let's make sure that we got this right. Let's just check it. So 15 times 3 is what? 45. Good job. 15, 30, 45. Huh. That looks the same. It looks familiar. Plus, what is 15 times 4? 15, 30, 45, 60. Okay. Looks the same. Good job. We did it. Do you see how they are all exactly the same? The exact same numbers. Do you know that this here and this, they are exactly the same. It just looks different. They are exactly the same value though, but it looks different. Math is really so cool, you guys. We can move things around, we can make it look different, but even though we do that, it's all the same. And sometimes we want to change things because it makes math easier to do, and that's a skill that we're going to practice. We're practicing that now, and later we're going to use it more. Why? Because it's going to make math easier later. That's pretty cool. Let's try another one. Often, when we see the distributive property being used, really it looks like this. And so what we're doing is we want to use this to change it to, so I have two bigger numbers that I'm going to be adding together. How do we do that? we're going to distribute. We're going to use that distributive property. We're going to multiply both the numbers inside by 9. It's kind of similar like last time. So look, like this. So what is 9 times 3? Good job. It's 27. We're going to bring down the plus sign. What's 9 times 2? 18. Good job. And we're done. Oh, wait. There, show the arrow there. Okay. I told you, people forget to do that. I don't know why. People just forget to multiply by that last number. So these are the same. 9 times 3 is what? We got 27. Multiply that plus 9 times 2, 18. These are the same. So I just wanted to show you this. We can do it both ways. Let's try that first one more time. Let's try one more problem. What is 120 plus 36? Oh, hold on. I don't really want the answer. I want to write this in a different way using the distributive property. So get your paper, and I want you to try it with me, right? Or, hey, you could try it first and see if you get it right, and then check it with me. So just hit pause on the video. All right, so let's draw our upside down division. What's the first number we can pull out? I always like to start with 2. Are both numbers even? Yes, they are. We can pull that 2 out. Ooh, 120 divided by 2. Well, 12 divided by 2 is 6. And then I can just bring down that 0. Okay. 36 divided by 2. Well, 3 divided by 2 goes in there one time and leaves me 16 divided by 2, 8. Okay. Again, you can use a calculator. Totally fine. So I got 60 and 18. Are they both divisible by 2? Yes, they are. They are both even. So 60 divided by 2 is 30. Good job. 18 divided by 2? 9. Good. You're doing this on your paper, right? Ooh, careful, I'm going to write on me. Make sure you're writing this on your paper too. Good job. Oh no, we're stuck. There's no more we can do. Just kidding. Let's try 3. Okay, so 3 works. Yep. What's 30 divided by 3? You got it. 10. 9 divided by 3. Yep, 3. Oh, we're done. But they're not like the counting numbers where they're right next to each other, 10 or 11. They're not together. Remember, I warned you before, that doesn't always work. We know that the factors of 3 are just 1 and 3. And I know that we don't use 1 because, well, it doesn't change anything. So we don't use the 1. And the 3, we can't divide 10 by 3, so we know we're done. Okay. So 120 and 36. Let's rewrite this using the distributive property. So remember, we say 2 times 2 times 3. What's that equal? 2 times 2 is 4, times 3 is 12. So we bring it straight down. We write 12. Now we add the parenthesis. And all we have to do now is bring down the leftovers. Bring down the leftovers, right. 10. Bring down the plus sign. 3. There we go. We are all done. Easy. So I'm telling you that this 120 plus 36 is exactly the same as 12 times 10 plus 3. Let's check it and make sure. What's 12 times 10? So I can just take the 12 and add a 0. Look at that, 120, cool. Bring down the plus sign. Now I'm going to say what's 12 times 3? 12 times 3 is 12, 24, 36, 36. Okay. Hey, look at there. Exactly the same. It is perfect. We did a perfect job. All right, so now we've learned a different way that we can write two big numbers that we're adding together. We don't actually want to know what it equals. We just want to see the different way to write it. And that's going to be useful using the distributive property. Good job. I know it's a little bit of a strange concept, but you did really good work with this today. So, thank you. It's good to see you. I hope to see you next time. Have a great day. Bye.